Hey everybody, Mr. Mac here. We are looking at 1.2 exponents, and we're going to look over the rules of exponents, and I am going through the examples here from the OpenStax book here that you all have access to, and there's way more information in the ebook, and I'm just distilling it down here for you guys. And so let's take a look at our first rule, the product rule. And notice it's important for all of our bases to be the same for these rules. So for this one, we have a to the m times a to the n. And what we can see here in a here, I'm expanding the powers here that we can count and see that, okay, we have 8 of them. So this would be t to the 8th. And we're just going to add our exponents when we multiply expressions that have the same base. So this would be t to the 5th times t to the 3rd. It would be t to the 5th plus t to the 3rd, which is t to the 8th would be our final answer. Example B, we have the same base here as -3. So -3 to the 5th times -3 to the 1st. We're just going to add the exponents and get -3 to the 6th. Keep that base in parentheses. Here we've got 3 expressions with the same base. Again, we're just going to add the exponents. And in this case, we're going to get x to the 10th. Okay, so let's take a look at the quotient rule. A to the m divided by a to the n. In this case, we're going to subtract the exponents. So example A, our base is -2. Just writing down the rule here. So we're going to subtract 14 minus 9. So our answer is going to be -2. Keep that in parentheses. To the 5th. So if I were to expand it, don't write this, but if I were to expand it, this is what the expression would look like. As you could see, I would cancel all but 5 of those -2's. Just finishing up these last two here for you guys, you can see we just subtract the exponents when we have the same base, and we're done. That's the quotient rule. Power rule, so if we are going to raise an expression by an exponent, we're going to multiply. So in A here, I've expanded the x squared 7 times. And as we could see, we would add all the 2's here, and we have 7 of them, so that would be 14. So more simply, we can just multiply the 2 times 7, which is x to the 14th. That's the power rule. We're going to see that in B. Our base is 2t. We're going to multiply 5 times 3. We get 15. And then we get -3 to the 55th for part C. Alright, so the 0 exponent rule. If I raise a base to the 0, it would be 1. So let's use the quotient rule to understand. Here, if I have c to the 3rd over c to the 3rd, and I expand that, we see that everything just cancels. Well, we know that's 1. So c to the 3rd divided by c to the 3rd would be the same as c to the 3 minus 3. C to the 0 is 1. We can see that in part B. Our x to the 5th terms would cancel. In part C, I'm going to combine the denominator by using the rule to add my exponents. And then notice I have the same expression in the numerator and denominator. Therefore, they would both cancel. So j to the 2nd times k all raised to the 0 would be 1. our last example here, I hope you see that it's the same expression, numerator and denominator, so those would cancel. Just leave us with 5. Okay, so let's take a look at negative exponents. Our negative rule is a to the negative n equals 1 over a to the positive n. And all these examples we're going to see when we use the quotient rule, we'll get a negative exponent. Well, as you can see, when I expand the theta to the third over theta to the 10th, we would get 1 over theta to the 7th when we canceled. So we can see the quicker way is just to use the quotient rule, get our negative exponent, and then flip it into the denominator to make it positive. We're going to see this with the next two examples. We use the quotient rule here, and we're going to and the product rule, so we get z to the second minus 4 plus 1 simplifies to z to the negative 1. We want to write it as a positive exponent. We put it in the denominator. We use the quotient rule for c. We do 4 minus 8 on our base, and that gives us a negative 4. We want to write it as a positive exponent, so we're going to put it in the denominator and write the exponent as a positive 4. Okay, so that's the negative exponent rule. Now what do we got? We got two. We have the power of a product and the power of a quotient. Okay. So a times b all raised to the nth is equivalent to a to the nth times b to the nth. So right here we're just using the negative exponent rule again for part A. For part B, same thing. We're going to add the exponents, negative x to the 0 power. That's going to be 1. Part C, we got the same base, negative 7z. We're going to use the quotient rule to subtract, and we're going to write it as a positive exponent by putting it in the denominator. That one's done. Okay. We're just applying some of the rules we've already done here. Okay, we got power rule here again. So let's rewrite this expression as a to the first, b to the second, all raised to the third. We're going to distribute the 3 into the other two exponents. So 1 times 3 and 2 times 3. So a to the third, b to the 6th is our final answer, simplified. And part B, don't forget that 2 has an exponent of 1, and we're going to distribute the 15 into both of those. And so we can use a calculator to find what is 2 to the 15th here, and it's 32,768 t to the 15th. Okay, part C, we have same thing. T to the first times 3 times w to the third times 3. I'm going to distribute the exponent. Should probably put that in parentheses, that negative 2 base. Same here. I'll put this in print. There we go. Let's fix that. Negative 7 to the 4th, z to the 4th. I distribute the exponent using the power rule. Let's expand that. Negative 7 to the 4th is 2401. And then we got the last one here. Okay, in part E, we're going to distribute the 7 into both these powers, and then we're going to make the exponents positive, as we see, using the power of a quotient rule. Okay, So we have a divided by b raised to the n. So I've got a few examples here, and I'm just going to rewrite this. We say 4 to the first. We'll multiply the exponent of 3 to that first power, z to the 11 times 3. We get 4 to the third over z to the 33rd. And I think I'll just leave it like that. P over q to the third, well, that's p to the first times 6, q to the third times 6. And so we get p to the 6 over q to the 18th. Positive exponents, that's done. C, we're going to distribute the exponent 27 times 1 and t to the second times 27. So negative 1 raised to an odd power would give us negative 1. If we were to raise that to an even power, it would be a positive number. Okay, so let's take a look at these last two here. We've got j to the third, k to the negative 2, all raised to the fourth, so we're going to distribute the 4 into the exponents here. We're going to make the k base a positive exponent by putting it in the denominator. Last one for e, distribute the 3. We're going to get m to the negative 6, n to the negative 6. Take the reciprocal here to get positive exponents. Last example set here, we're going to simplify and write using positive exponents only. Don't forget to distribute on the constants here. 6, we can write as 6 to the first, so we're distributing 3 times 1. That expands to 216. We'll write the n as a positive exponent. Part B here, we have the same base here, 17. So we're just going to use the product rule and add the exponents. And we want to write the exponents as a positive. And I can expand that to 1 over 289. Part C, distribute the power of 2. We've got a v term in the numerator and denominator. I could use the quotient rule and write the exponent for u as a positive. Let's multiply these two expressions for d here, negative 2 times 5, and a to the third times a to the negative second, and b to the negative 1 times b to the second. Just going to use our rules here to simplify. And no negative exponents, so we'll leave it just like that. E looks hard at first until you realize that the bases are the same, and when we use the product rule, we get a 0 exponent, which is 1. So that was easy. Let's expand the numerator and denominator here for f and then see if we can simplify. So 3 to the 5th is 243. We use a quotient rule for our w. And 6 to the second is 36. And there's a common factor here of 9 for the constants in the numerator and denominator. So try dividing that out and see if you can get what I get here. And I think that we're done.